Hi, this is George Woodbury from College of the Sequoias in Visalia, California, and in this video I'm going to go over solving quadratic equations by completing the square. Completing the square ideally works when you have a trinomial where the leading coefficient of the squared term is 1 and the coefficient of the linear term is even. But you cannot factor the trinomial that you have. Here's another leading coefficient of 1, linear coefficient that's even. You can do it with an odd linear term as well. It's not the most convenient, and I'll explain that when we get there. I'll do one like this as well. If you have an equation where the leading coefficient is not 1, I think you're better off using quadratic formula here. You could divide everything by 2, but you know when you divide these by 2, you're introducing fractions, and there's a lot of headaches that go with this. I think quadratic formula is definitely safer in this instance. So let's go ahead and take a look at the steps. We'll begin by isolating all the variable terms on one side of the equation with the constant term on the other. We'll take half of the linear term's coefficient, square it, and add it to both sides of the equation. If your equation is of this form, ax squared plus bx plus c, after we isolate the variables, ax squared plus bx equals negative c, we're going to take b, divide that in half, square it, and add it to both sides. The left side will be a perfect square trinomial. We'll factor that, and then we'll solve by extracting square roots. Basically, the idea is to take an equation that we didn't know how to solve and changing it to a form that we know how to handle by extracting square roots. And here's the first example. I look at this problem. This trinomial can't be factored, so I'm going to go ahead and subtract 4 from both sides. That gives me x squared plus 8x equals negative 4. Now I'm going to take this coefficient of 8, I'm going to divide it in half, and I'm going to square it. 8 divided by 2 is 4, 4 squared is 16, so I'm going to add 16 to both sides. I'll factor what's on the left. That factors to be x plus 4 times x plus 4, or x plus 4 squared. The right side becomes 12. Now I've got it in a form where I can solve it by extracting square roots. I have a square equal to a number. Square root of both sides, plus or minus on the right. The left side is just x plus 4. 12 is 4 times 3, so I can take out a 2. That's plus or minus 2 root 3. And then I'm going to subtract the 4 to the other side. X equals negative 4 plus or minus 2 root 3. That's negative 4 minus 2 root 3 and negative 4 plus 2 root 3. So again, isolate the variable terms first. Add the magic number half of b squared to both sides. Then we solve by completing the square. So let's try it again. I don't think I can factor this. You really want to apply the 5-second rule. If you can't factor it quickly, then move on to try something else. Because the linear term has a coefficient that's even, this is going to be an easier approach to use completing the square. Isolate by adding 85 to both sides. I take half of negative 12 and square it. Negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So I'm going to add 36 to both sides. The left side factors to be x minus 6 squared. The right side factors to be adds to be 121. Once we have the square, we take the square root of both sides. Simplify. That's going to be x minus 6. The square root of 121 happens to be 11. When the square root disappears and there's no I left either, that means that you could have factored, and I'll come back and show you that in a minute. I'm going to add 6 over to the right hand side. X equals 6 plus or minus 11. 6 plus 11 is 17. 6 minus 11 is negative 5. So our solution set is negative 5, 17. Now, I couldn't factor that right away by sight, so I went to a different approach. But if I could have factored this quickly as x plus 5 times x minus 17, I know that my two solutions are going to be negative 5 and positive 17 a lot quicker than going through this. Notice here that all three terms have a common factor of 4. I'm going to factor that out first. And I can divide both sides by 4, leaving me with this equation: x squared plus 2x plus 14 equals 0. That doesn't factor. I've got an even linear term. I'm going to subtract 14, add half of the linear coefficient to both sides. That's 1 squared, or 1. So I get x plus 1 squared equals negative 13. I take the square root of both sides, plus or minus on the right, and I have x plus 1 equals plus or minus I root 13. Subtract the 1, x equals negative 1 plus or minus I root 13. So in solution set notation, negative 1 minus I root 13, negative 1 plus I root 13. So if your leading coefficient is not equal to 1, you can always divide everything through by that number and solve the resulting equation. One to go here. Now I want you to notice this one does factor. If I were to solve this by factoring, I have x minus 6 times x plus 3 equals 0. I immediately know that my solutions are going to be positive 6 or negative 3. Okay. That's real quick and to the point. If you don't notice that and you need to try something else, then that's the way it goes. I'm going to add 18 to both sides here. I have half of negative 3 squared is positive 9/4. So I'm going to add 9/4 to both sides. Okay. We can already see that when the middle term, the linear term, has an odd coefficient, it's going to get a little messy because of the fractions. Now the left side isn't as bad as you might think. This factors to be x minus 3/2 squared. Negative 3/2 was half of that coefficient. X minus 3/2 is the factored form. To add 18 plus 9/4, I have to know that 18 over 1 is the same as 72 over 4. And when I add 9/4 to that, I get 81 over 4. Square root of both sides, plus or minus on the right. I have x minus 3/2 equals plus or minus, see, the square root of 81 is 9, square root of 4 is 2. Add the 3/2 over. I have 3/2 plus or minus 9/2. Let's see, the first solution, 3/2 plus 9/2 is 12/2, or 6. And 3/2 minus 9/2 is negative 6/2, or negative 3. And notice those are the same solutions that I had at the very beginning without all the hassle. Okay. If you have any questions or comments on this video, or if you have a request for a video that I can put together for you on YouTube, you can reach me through the contact page on my website, and that address is georgewoodbury.com. Thanks and good luck.